Hey guys, it's Shaheer from 5 Academy. So today we're going to be going through the last part of the 52 ACT Math Skills video series. I have a set of about 10 different problems from 10 different problem types here that I'm going to go through. Each of these is supposed to give you an idea of what this particular skill can typically look like on the ACT Math test. So what you can do with this video and this video series is next time you take a practice exam and you're looking at which questions you got wrong, use this video series to categorize the problems you didn't get right. Categorize them by skill and do this over the course of your 6, 8, 12, whatever the number is, practice exams, and you'll start to see patterns in what particular things you need to work on most. And then you can actually work on those things and improve on them. This will help you understand skills better on the math test and eventually improve your math score because math is very skill heavy. We'll have videos like this for English as well, so you can do the same type of exercise. So these are the problems that I'm going to go through. Like I said, there's about 10 of them, 10 or 11, I think. And without further ado, let's get... Oh, one more thing. If you want any more practice content, if you want problems and videos that actually teach you each of these skills individually, as opposed to just showing you what they are, check out our website. We have lots of online content that lots of students have found helpful. The content is paid, but I think at $39 a month, hopefully it should be workable or definitely cheaper than a lot of the other resources for the ACT that are available. We have thousands of online problems as well as hundreds of videos that teach you the skills and the strategies for these tests. So without further ado, let's get started. First skill that I want to go through is operations with scientific notation. So scientific notation is when you have some decimal like this times 10 to the something. And essentially, it's just another way of writing numbers that would end up having lots of zeros. So when you want to do multiplication, division, addition, subtraction of numbers like this is a typical example. This is multiplication. With multiplication, division, it's pretty straightforward. You can just plug it into your calculator. Even with addition, subtraction, you could plug it into your calculator. So that's a pretty surefire way of getting it right, as long as you know how to plug it into your calculator correctly. However, with this one, I'll show you how to do it by hand. So this is just a multiplication problem, right? So what we're going to do is we're going to split the problem into two things. There's going to be the part with the decimals, and then there's going to be the part with the exponents. Okay, so what you do is you do the multiplication of the decimals first, and then you do the multiplication of the exponents after. So what's 1.3 times 1.111? This ends up giving you, I believe it is 1.3 times 1.11. This gives you 1.443. And then what is 10 to the 6th times 10 to the 0? Well, 10 to the 0 is just equal to 1, so it's just going to be 10 to the 6th. Okay, so your answer is just going to be these two things combined together times 10 to the 6th. 1.44 times 10 to the 6th. Okay, pretty straightforward. Which of the following sorts the fractions below in decreasing order? So with these, it's very, very straightforward. This is an ordering fractions problem. What you do is you just plug in each of these fractions into your calculator. So 7 over 6 is going to be 1.16 repeating. This 16 over 13 is going to be 1.23. And then 11 over 9 is going to be 1.2 repeating. Okay, so once you have the decimal equivalents, you can obviously sort them. So decreasing order, the biggest is 1.23. Then we have 1.2 repeating. Then we have 1.16 repeating. Okay, and then after this, you convert these back into their fraction form. So this is going to be 16 over 13, this is going to be 11 over 9, and this is going to be 7 over 6. So your answer is going to be E, okay? Very straightforward. It took me 20 seconds to do it, but use your calculator for this type of problem. It really makes life a lot easier. Next problem type is properties of exponents. So this is where you're going to be given some weird exponent expression like this, and you're asked to find an equivalent statement or evaluate the statement. So with this particular type of, there's a variety of properties of exponents. You can look them up on Google Images. You'll get a list of them. That's really nice. You can also find it on our website. But essentially, this is one of the properties where you have a negative exponent. So clearly, like 2 to the second, I can easily evaluate that. That's just 2 times 2, that's 4. But 2 to the negative second is not exactly as simple. What you have to do is you actually have to turn the number into a fraction. So 27 to the negative 3, let me write it this way. A to the negative b is actually equal to a 1 divided by a to the b. So 27 to the negative 3 is equal to 1 over 27 to the third. And that's the same thing as, you can even rewrite it as 1 to the third over 27 to the third, or as 1 over 27 to the third. Okay, there's a couple different properties that I used in converting from this to this, and then this to this, and then eventually from this to this. So you need to know those properties in order to be able to do these problems correctly. So the answer here is going to be this right here. Which of the following is a solution to the quadratic equation below? So this is the skill about quadratic formula. If you're not familiar, the quadratic formula is this, divided by 2a, and this is for a quadratic equation in the form y equals ax squared plus bx plus c, and this is specifically applicable where this y is equal to 0. Okay, y equals 0, right? So when we're trying to find the x-intercepts effectively, we can plug this type of equation into this form, okay? I'm not going to do it. I'll let you do it and try to get the right answer. But the formula is right here. And remember, you need to know this in order to do problems like this where you can't just factor them or use the box method. Next problem type is about rational or irrational numbers. So which of the following expressions results in an irrational number when simplified? Remember that an irrational number is just a number that can't be written as a fraction of whole numbers, okay? So a fraction of whole numbers like 3 over 4, this is rational. 5 over 6, that's rational. 16 over 22, that's rational. 1 over 3 is rational. However, pi over 3 is not, because pi is not a whole number. E is not rational. I, even if it's divided by some other whole number, these are not rational. These are not rational, okay? Square root of 2 over 5 is not rational, because square root of 2 is not a whole number. Square root of 4 is a whole number. This ends up becoming 2 over 2, which is equal to 1, but that's different, okay? So knowing that, we can go ahead and evaluate this. I know in this case, square root of 27, this doesn't work because square root of 27, if you just do it on your calculator, it's not going to give you a whole number. This one, actually, yeah, so this is going to be irrational, understanding this correctly. This one's going to give you 9 over 2, so this is rational. This one's going to give you, actually, this one might not be irrational. Let me explain. So what you can do in this case is you can actually expand this to be 27 over 243, which is going to give you equals 1 over 9 square root, and that's just going to be 1 over 3. So this is going to be rational. This is going to be square root of 9, which is equal to 3. It's rational. This is going to be 243 divided by 3. It's going to be square root of 243 over 3. This ends up being square root of 81, which equals 9. That means your answer has to be this, which is going to be square root of 81 divided by 27, and that just equals square root of 3. Okay, so that's going to be your irrational. All right, if that makes sense, again, can't be written as a fraction of whole numbers. Next problem type, which of the following values for x are solutions to the absolute value equation below? This is a better version of it, right? So solving absolute value equations. This is another very important skill. You have to be able to do this. So in general, the way you do it is you first isolate the absolute value bracket, okay? So let's isolate it, move the 3 to the other side. So we get absolute value of 2x plus 1 equals 7, okay? So we did that. Second step is to break it into 2 equations, break into 2. So the first one is where you just take the equation and remove the absolute value brackets. And the second one is where you do the same thing, but you put parentheses around it and make it negative, okay? So they're really the same thing, but one is just a negative version of the other, okay? And then you solve both. You're gonna get 2 answers, most likely. Negative 2x minus 1 equals 7. Plus 1, negative 2x equals 8. That means x equals negative 4. So you have 2 answers, x equals 3 and x equals negative 4. That's why D is correct. Moving on. So the graph of this equation is in the coordinate plane. Which of the following transformations, when applied, results in the graph of this? So transformations, translations, reflections. This is another skill, basically stretching, shrinking graphs. Just for some background. Let's say I give you a graph that looks like this, and then I turned it into a graph that looks like this. So what I did, and this is a poor drawing, what I did effectively is I shrank the graph vertically. Another example is a graph that looks like this, and I make it more vertically stretched by making it look like that. Okay, so that's kind of what this skill is about. That's a visual explanation, but the equation explanation is another aspect of it that you should know. So in this case, what we're doing is we're effectively if you look at the 2 functions, if you just eyeball them and look at the difference, we take this and you basically multiply all the terms by 4 and you get this. When you do that, when you take one equation, like let's say this is called f of x and this is called g of x, when g of x is equal to just 4 times f of x, that means that g of x is a stretch vertically by factor of 4, okay? And transformations, this is another thing that you kind of just need to memorize. For example, if this was 1 over 4, then this would be a vertical shrink by 1/4. There's horizontal stretches, shrinks. There's translations where you move a graph up, right, left, down. I'm not going to get into all that here, but just so you know, if you see something like this where it's like you take one equation, you turn it into this, just know it's translations, transformations, reflections, shrinks, stretches, etc. The bar graph below shows the distribution of grades students received on a recent quiz in this person's class. What proportion of students in the class received C or D grades? So this skill is all about analyzing frequency counts. So this is a frequency count, right? You have this particular category and this is the frequency. This particular category, this is the frequency. So analyzing frequency counts, again, you're basically extracting basic data from these graphs that you're given. So in this case, what proportion received C or D? This means you count up the C's and the D's. So in this case, this is going to be 7. This is going to be 3. You get 10. And the total is what? It looks like all the denominators are 26. So I'm going to assume it's a 26. This gives you 5 over 13. Unless I did something wrong. But I think this looks right. It's 10 over 26, so it's really the same thing. It's just not simplified in the answer option. But the idea is you're basically just taking basic data. It could be asking you for a mean, median, mode. Like if it asked you for the average score, you'd have to, obviously you can't count up all of these and then divide by the number of scores. But what you could do is you could count up and try to find the median or the midpoint of all of these. It would be somewhere in the C or B region. So that's kind of how these problem types work. I think we have 2 left. So 2 dogs are in Sam's backyard. Each leash is tied to its own tree. The 2 trees are this far apart. One leash is this long, the other is this long. If the dogs extend their leashes as far as possible in the direction opposite of the tree, for how many feet do the 2 leashes overlap? So just for some visual, this is a tree, this is a tree. We have a leash for one dog going this way. Also just the distance between is 12. This one is going 7 feet. This one is going, let's do it in a different color. This one's going 8 feet. So how much overlap? This skill is all about Venn diagrams and counting. So effectively, think of this particular circle as representing the range of reach of the 7-foot leash. And then this other circle represents the reach of the other leash. It's clearly a little bit bigger, right? This is obviously not drawn to scale. So we effectively have a Venn diagram, but we need to count the distance between that's overlapping, the maximum distance of overlap. So for how many feet do they overlap? The way you can do this is, one way to do it is to just count up the 2 items and then see how much they exceed the total distance. So 8 plus 7 equals 15. That's just 3 greater than 12. That means that there's 3 feet of overlap. Okay, that's one way to do it. Another way to do it is to notice that if this is 12 and this is 7, you can know that your midpoint is 6, which is right here. This is 6 feet in this direction, right? 6 feet. Which means that what's left right here is 1 foot. Right? Because to go, the only difference between this blue guy here and this red guy, again, not drawn to scale, is that 1 foot. And if I go from here to here, again, I know this is 6 feet because I'm going to the midpoint, right? From here to the midpoint of this guy is 6 feet. That means that whatever is left here is just the difference between 6 and 8. That's 2 feet. So if I add up this guy with this guy, I get 2 plus 1, that's 3 feet. Okay? This is one way to do it. There's actually 2 ways to do it. So hopefully this helps. You're going to get problems like this. This has shown up a number of times in the last 10 problems. All right, last problem type. The 2 numbers have a sum of this and a difference of this. The 2 numbers multiplied together gives a value of what? So this is called word to algebra translation. You're taking a word problem and basically putting it into math terms and maybe even solving it. So 2 numbers have a sum of 10. Let's just say the 2 numbers are x and y. The sum is 10. That means they add up to 10. And the difference is 8. X minus y equals 8. The 2 numbers multiplied together gives what? So first we need to obviously find x and y. Let's do that by turning this into a system of linear equations. So I'm going to solve this for x. X equals y plus 8. And then I'll plug this x into here. So y plus 8, right? This is originally x, plus y equals 10. So 2y plus 8 equals 10. Minus 8 minus 8. I get 2y equals 2. That means y equals 1. Okay, y equals 1. Now I'll just plug this into either one of these equations. They're all going to be true. Y equals 1, so x equals 1 plus 8 equals 9. Okay, x equals 9. Y equals 1. Y equals 9. That's your answer right there, okay? So hopefully this breakdown was helpful. We've completed the 52 ACT Math Skills video series. If you want any more explanation on any of these skills, feel free to leave a comment below and we can make a video going through each of these a little more in depth if you like. But that's really what our website is for. We go through all of these. We teach you these through in-depth videos that really discuss all aspects of each of these, not just a high-level quick overview, more so in depth and teaching you the little nuances and how exactly they can show up beyond just one type of problem. So if you want to check that out, see the link below. We have lots of content on our website, as well as tutoring resources with myself and some of our other experts. Without further ado, I'm going to leave the video at that. Hopefully this series was helpful. And if you have any comments, questions, concerns, let us know on our website or in the comments below. Thanks.